Okay, so this is the sample linear regression part 3. So basically, I'm going to briefly, going to talk about the test individual regression parameters. So in the previous chapter, we learned about the hypothesis testing, right? So we are going to apply what we learned, the hypothesis testing, on this regression parameters. Okay, so basically, we can first task is always, right? The first task is always to set up the null and alternative hypothesis. Okay, basically, the null hypothesis is saying that there is no relationship between an x and y, and x being a independent variable and y being a dependent variable, right? So basically, the null hypothesis, right, is there's no relationship, right? There's no effect, right? And obviously, the alternative hypothesis, yes, there is a relationship, there is an effect between x and y, right? Okay, between x and y. So, okay. So let's say from the population, right? So this is like a populations. So this is a population, the population parameters, right? And basically, this is x and y, right? And let's say this is like true regression line, right? Because we have all the all the data, right? It's going to be the many data because it's about the populations. So this is like an accurate model, right? This is representing the true, right? The true regression line because it's based on the population, right? But this is not available, right? I mean, that's why we need to have a sample, right? And then from the sample, we can get the estimated regression lines, right, from the sample. Because sample, we don't have many data set compared to the population. So the true equation, right, for the this regression line is what? It's y, right? Y is equal to b naught plus b, the beta 1, right, x, right? And whereas the sample, right, the equation is y hat equal to b naught and b1, right? So the b1 is the estimate, right? This is estimate for the beta 1, and the b naught is an estimate for the beta naught, right? Okay, so this is x. Okay, so if I just rewrite, right? If you just rewrite this null and alternative hypothesis, there's no relationship. By the way, you know that it's null and alternative hypothesis is all about what? It's all about population parameter, right? It's never about the sample parameters, right? It's always is all about the population parameter. So in this case, what is the population parameters? The beta 1, which is a slope, right? The slope. And then the beta naught, which is the intercept, right? So it's all about the population parameter. In this case, there's no effect between an x and y. That means when the slope is a 0, right? Then there's no relationship. Okay, if this is a 0, what it really means is this. So this is like population parameters, right? And this is x and y. So that means we have a population data, right? It's many millions, right? And then if the beta is a 0, then the slope is a 0. So basically, you have this line, right? So as you can see, there's no relationship between an x and y. So that's really about the what? It's about the null hypothesis, right? And alternative hypothesis is opposite, right? Alternative hypothesis is that the beta 1, right, is not 0, right? It's not 0. So that means there's a slope, right? Whether it's a positive or the negative slope, right? By the way, this is negative slope and this is positive slope. So this is beta is, and this is what beta 1 is less than 0, right? Okay. So anyway, what I'm trying to say here is the beta 1 is not 0. It could be negative and a positive, but there's some relationship between x and y. Okay. So that's the how we can set up this null and alternative hypothesis, right? By the way, this is what you know that this is not equal means what we are talking about the two-tailed, right? Two-tailed testing. Okay, so that's the basic setup, right? That's a basic initial setup. Okay. Okay, so if you just review, right? I mean, if you recall what we learned in previous lecture, right? In my previous lecture, we have a populations, right? We have a populations, and then we get the samples, right? Samples, and then we get another samples and another samples and another sample, right? If we just do it like infinite times, we know that this B1, right? Because this data, we can get this data from the sample. So we can get that data sample from this sample, right? All the samples. We know that we can, this B1, right? The value of the B1 will follow the normal distribution. So basically this is a sampling distribution of the sample B1, right? I'll say this is like a sampling distribution of B1. And if null hypothesis is true, right? We know that B1 should be 0, right? So we know that this is like, I'm talking about that this is B1, the sampling distribution of the B1. And if the null hypothesis is true, we know that will be centered around the B1 is equal to 0, right? Which is the same as the population slope, right? Which is beta 1 is equal to 0, right? So since we don't know the the population variance, we have to use the t distributions, right? So let's say this is our t distributions, and then we know that the center, the value is always a 0, right? T is equal to 0. We convert this B1 to t value, then the center is always 0, right? Okay. Then we find the t statistics, right? The t stat value. And then if t stat value is really far away from the mean, right? If your t stat value is t stat values are really far away from the mean, that means what? That's a strong evidence against null hypothesis, right? So basically remember, if it's a two-tailed case, right? So let's say this is your t statistic value, right? From a sample, right? And then since it's a two-tail, your p value is what? Your p value is 2 multiplied by either left area. So let's say this is a left area, right? And then let's say this is a right area. So left area or 2 multiplied by right area, right? This is something that we learned. So that's a p-value actually, okay? And so, okay, that's a p-value. And when it comes to regression, right? The linear regression, we're going to use a tool, like for example, such as Excel, right? And Excel will find the p-value for us, okay? And then, so once we find a p-value, right? So what is our rejection rule? Our rejection rule is what? This is, by the way, this is a review. Okay, so the rejection rule is right? Rejection rule is what? If the p-value, right, is less than alpha, the level of significance, it could be what, of the 5%, right, meaning that 0.05, whether your level of significance could be 1%, right? That means 0.01, right? So then in this case, is your confidence level is 95%, then this is like 99%, right? So in this case, is your confidence level is 95%. In this case, your confidence level is of CL, sorry. Your confidence level is 95%, right? Oops. And then your confidence level is what? In this case, is 99%, right? But anyway, if your p-value is less than alpha, right? Then means what? That means there's a strong evidence against null hypothesis, right? So you reject null hypothesis, right? And otherwise, if your p-value is greater than this level of significance, right? Then what is the rule? The rule is the fail to reject a null hypothesis, right? Okay, so that's the rule, right? I mean, so the good thing is, that the tool, right? Typically many tools like the R and then Excel, right? They can, if you run this scenario, right? They will provide you the p-value, okay? And then you can make the decision, right? Okay, so in my next lecture, I'll show you how to use an Excel spreadsheet to find the p-value when the sample, right? When the sample data is given. Okay, so that's like a last topic in a simple linear regression model. Okay.